Hello everyone, welcome back to my channel. Today we are going to talk about selection sort, which is one of the easiest sorting algorithm to understand. So let's take an example of array and try to understand how selection sort works. So let's create an array. Our array will be 5, 9, 1, 4, 3. Okay. The basic idea of selection sort is we split this array into two parts. One is sorted part and another is unsorted part. Okay. Now, initially, the sorted part will be empty and this all element will be part of unsorted array. Okay. We will look into the unsorted array first and find the minimum element here. Okay. So if you see in this unsorted array, what is the minimum element? Minimum is 1, right? So what we'll do, we will swap this 1 to the first element of unsorted array, right? Now our array will look like something this: 1, 9, 5, 4, 3, right? So if you see here, this now becomes the sorted part of the array and this becomes unsorted part of array. Okay. Now we have to repeat the same process again and again. Okay. Now again, let's find the minimum into this unsorted array. So minimum is 3, right? So we will swap this to 9. Okay. So after this, our array will look like something: 1, 3, 5, 4, 9, right? First pass after second pass. Okay. So same thing here. Now the sorted array is up to this and this is unsorted part, right? So again, same thing we will do. We will find minimum into the unsorted part. So minimum is 4. So we will swap 4 to 5, right? So swapping will happen from here. After swap, now the array will look like 1, 3, 4, 5, 9, right? This is after third pass. Okay. Now array is sorted up to this and this is unsorted. Okay. Again, now we need to find the minimum in unsorted part. So 5 is the minimum, but no swap will happen because we need to swap with the first element of unsorted array. Okay. After fourth pass, we understand that we have got the sorted array, which is 1, 3, 4, 5, 9. Okay. This is sorted. So it's very simple. You need to find the minimum element into your array and then swap it with the first element of your unsorted array. And this you have to do until your array is sorted. Okay. So that's it about selection sort. Now we'll see how we can implement the selection sort and time and space complexity of selection sort. Now let's come to the selection sort method. First of all, let's take an variable n which will give us the array dot length. Okay. Now let's take a loop which will iterate through the array. Okay. So outer loop will be for int I equals to 0, I less than and minus 1, I plus plus. Okay. Now our first work is to find the minimum. Okay. So we'll take an index which is int mean index, which will initially point to I. Okay. Now we'll take the inner for loop which will iterate through the unsorted array, okay, and find the minimum of that unsorted array, okay. So this will start int j equals to I plus 1, okay, and then j is less than n and j plus plus. So why we have put I plus 1? Because we have to compare the minimum and the next element, okay. So we'll find the minimum here, okay. So how we'll do that? We will write if condition if array of j is less than array of mean index, okay. If this condition satisfy, obviously we need to set j as the minimum index, right? So mean index equals to j. So we'll keep on doing this until we find the minimum element, okay. It's simple. Once you find the minimum element, we'll come out of the for loop, okay, and we swap only if needed. What does that mean is, if mean index not equals to I, which obviously if you remember we saw here, since 5 was the minimum in this unsorted array and this is the first element of unsorted array, so we don't need to swap, right? So if minimum index is not equals to I, then only we'll do the swap. So simple, we'll take int temp equals to array of mean index, right, and array of mean index equals to array of I and array of I equals to temp, okay. So this is how we can code selection sort in optimal way. Now let's try to run this main method. So you can see now array is sorted, right? So this is how you can implement the selection sort. So if we talk about the time and space complexity, so we can see, right, we have one for loop to iterate through the array and one for loop to find the minimum into the unsorted array, right? So since we have two nested for loops, okay, so the time complexity here will be big O of n square. So in best, average and worst, in all cases selection sort give you big O of n square. And space complexity, since we are not using any extra space, so it will be constant only. So if you compare selection sort with insertion and bubble, right, so selection sort is better than bubble sort because obviously uh, s- it does minimum swapping, right, and it is not better than insertion sort because obviously we need to iterate through the complete array to find the minimum each time, right? So insertion sort is best for a small and nearly sorted arrays, while selection sort is best when swaps are expensive. And bubble sort is just for the educational purpose, right? Just to practice. So the insertion sort is better than selection sort, but whenever swap is expensive operation, we can use selection sort, right? So that's it for this video. If you have liked the video, please subscribe our channel, and in next video we will learn about quicksort.